Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 57, we will be covering querying with GIS. So the different concepts that we will cover will be what is querying with GIS, then how to select the layers first, then we will talk about interactive selection, then select by attributes, which is where you will see the application of SQL queries in GIS, and then select by location, which is also known as spatial query, which is another way of applying queries, but using the power of GIS. And then we will talk about joins, spatial joins, and relates. So already we have learned querying earlier in details, and you have seen how query gives us a very powerful tool to fetch data from databases and to do many computations, or a lot of data analytics could be done via just querying itself. So now query could be also integrated with GIS as well. That means we being planners, that means that we are always working with spatial data, and we can always, when we are talking about geographic information systems, then we have got spatial data along with databases attached to it, or rather tables attached to it. So we can run queries over here to do a lot of analysis, and also not only to do analysis but to represent the data spatially. At the same point of time, because it's spatial data, it has got more information. For example, it has got a size, sometimes it has got a boundary. So all this additional information could be also used to do more advanced queries as well. So we will gradually demonstrate that. So query is a request to select features or records from a database. It is stated as a statement or logical expression. So already we have learned this. So queries could be done in several ways inside GIS. One is, first of all, we have to select layers. That itself is one sort of a selection of data or querying. So we call it basic selection. That means we can select the layers which we want to deal with, right, out of many layers. And then we can use manual selection or interactive selection, which is actually by clicking on certain features using the identify tool, or using the find tool or a distance tool. We can measure different things in an interactive manner. And that means we can also generate new data using this particular way. Then there is, or rather search data using this particular way. Then there could be selection by attributes, which is where we type in a SQL query, or in this particular case, because GIS and our software has become very interactive, we can just pick and pick up different criteria and actually set the criteria to create that query. And so once we set up those queries, we can also generate or get data or get an output from the data that we want. So these are similar to almost the database queries that we have done earlier when we are learning about database software. And then there is select by location, which is a spatial query, and then select by graphic. Select by graphic is now more or less similar to interactive. It's one way of interactive manual selection, where where features are selected using manually drawing graphic shapes, rectangle, polygon, circles, lines on a map instead of SQL or attribute conditions. And the GIS software that we will use in this particular lecture would be ArcGIS Pro, and and then there are several softwares. There is ArcMap, which is a much simpler version of ArcGIS, and ArcGIS Pro actually is the professional version which allows you all functionalities. Then there is QGIS, which is open source GIS. Then GrassGIS, which is we can do a lot of advanced spatial analysis with this. Then ADAS Imagine is there, where we can do remote sensing and raster analysis. MapInfo Professional is also another one where we can do a lot of similar kind of work that we are doing in ArcGIS Pro. So more or less, all this software offer a lot of common similar capabilities for mapping, spatial querying, and geospatial analysis. But in this particular case, we would be mostly using ArcGIS Pro, and we will use the latest version, and we will show you some examples from legacy old version, so that some people who are having the old version, they can also understand. So first we will look into how to select the layers. That means whenever you are running a query, we have to work with data and all. So we have to first select the layers for which we have to run the queries, right? So a selection layer is a temporary subset of features selected from the main layer based on condition or interaction, and original layer remains unchanged and selected features become highlighted, usually in blue and cyan, right? So first of all, we have to understand which layers we are going to select, and then within those layers, which are the features we are going to select, or which are the things we want to select from there, right? So all vector layers are selectable by default when added to the map, and layer selectivity is managed through the list by selection view in the table of contents in the software. So again, the software to software it will vary, but over here in ArcGIS Pro, you can see that we can list by selection, list by editing, list by snapping. There are different ways to see what layers are we dealing with. So list by drawing order, this is where you can see the layers are listed by drawing order. Drag and drop to change the drawing order, so we can move that. So that means which one should be edited first and in that order. Then list by data source, that means layers are listed as per their data source, that means from where the data is coming. So actually that also is, this is just selection of layers. And then list by selection is basically where layers are listed by whether their features are selectable by the interactive selection and editing tools or not. So that means over here you can see that the, in this, over here, these are the different layers which are selectable, and for this layer there are around 43 number of selected features that could be selected, right? And whereas this particular layers, these are JPEG files or certain kind of maps which are not selectable layers, right? So that actually is shown over here. Then list by editing, that actually layers are listed when by whether their features, geometry and attributes are editable or not, right? So there again we can have several maps. So raster layers cannot be edited, and so it actually shows us which layers we can do some amount of edit or not. And finally, list by snapping, layers are listed by their edit snapping status. Now, and also finally, list by labeling allows us to see the layers that are listed by their label class, and you can again this will vary from software to software. No need to bother too much about it. As you go about start using the software, you can select the layers which has got their labels, and we can, where labels are given, those are actually selected. And these layers, it could be also layers could be selected and prioritized based on the ability to display them on the image space, and that is where you can see that certain layers where it allows us to see features from an angled view or 3D visualization is possible. Those are listed, and this depends on if you are working with imagery, drone imagery, aerial surveys, probably we will try to list our layers like this. Then coming to the querying part, that is, we would first see how we can select through interaction. So first of all, interactive query means visually selecting features directly from the map interface using cursor based tools. So that means we can use the cursor to select which things we want to select. For example, over here first we go to selectable layers, and we can click and we can see if there are more for this particular object. If there are two layers, then it will give us both the options for which layer you want to select. If there is a single layer, then it will, when we click on that, it will give us detailed information about that particular aspect. So that means this is the first sort of querying. We are just selecting by clicking, right? So it's an interactive tool. And then we can also use sort of this selection via graphic sort of thing, where we can draw a polygon or a lasso or a circle to select the things that we want from that particular map, right? So that means here we have selected a polygon like this over here, and these are the features which are below that will get selected, right? So that's the basic querying or basic selection. Then what we can do is also something that we can create a new selection. We can add to a current selection, we can remove from correct selection, and we can select from correct selection, right? So that means once you are selecting something, then we can again, when I click, then I can say, is it for click adding to the current selection? So you can keep on data, or you can reduce, whatever you have selected. So these options are also there, and this actually is coming from an older version of ArcGIS, right? In the current version, it will look something like this. When you are selecting, you have to select, is it for new selection, or is it to add to a correct selection, or so on. Then we come to select by attributes, which is of more importance. We can write SQL queries here, or in most cases, in today's context, in current IDs, we don't even need to type in the queries, but in case of complicated queries, you probably have to. But simple queries could be just done by pick and choose, right? So we can, in ArcGIS, we can construct queries like select by attributes from the select by attributes tool, where we say that select star from layer name, where name equal to something, right? So that means the layer name is basically the table name, and where is the condition which is given, whatever is that particular feature, that for that particular feature, whatever is the name of whatever data you are choosing, that could be given here. So layer name also needs to be the currently selected layer, so that you can run queries on that. So query produces a new selected set of objects, and results will be shown in the map, and options for adding to a previous selection, removing from one, or selecting a subset from one, like earlier that we were discussing, that also is possible. And more complex queries can be also developed using AND, OR, NOT, or like we have done earlier, similar kind of queries could be also developed in case of GIS as well. So one example is select star from layer name, where name equal to XXX and store equal to Y. Results of a query can be exported either as a new layer or as a data table. So that means whatever we are getting as a query result, we can save it as a new data table or a new layer, and results can be also exported for further analysis to external software or to perform some statistical tests as well. So this is an example where in this, the latest version of ArcGIS software, we choose select by attributes, and then we select in this, we are selecting this particular table, and then this is like we are trying to select a state, and under select by attributes, we first choose the field which we want to choose, and it is a new selection. We are not adding to a selection or taking a subset. So this is a new selection that we have specified, and then we are saying where we are selecting the field, which is shape name is FID, this shape name, shape ISO, shape ID, shape group, and so on, which is equal to West Bengal, and that means this field is equal to West Bengal, and then when we do that, we will get the result like this. That means West Bengal is selected. Right. So that means whatever query you are running, you will get a result, and the result could be also viewed in a spatial context, right? So that means you can see the map of it as well. Now the next one is a little bit more complicated query, where we are not only selecting the state, we are selecting it where the number of household is greater than 24 lakhs and the population greater than 1 crore, right? So over here you can see the same thing we are doing. We are selecting the selecting that particular table, and then we are saying it's a new selection, and then we can where we are setting the field as number of households as means greater than 24 lakhs, and total population is also greater than 1 crore. Now if I tick the SQL editor, so here we could, like in case of new selection, or we can remove from current selection, we can switch from current selection. So all these options are there. Whichever you want, you can actually do. So that means you can select something and you can keep add to that, or you can remove from that, and you can keep on giving queries accordingly. And then when you are pressing on the SQL editor, you get to see the SQL editor over here, and here the command is being typed, and if you want to modify it from over here, that also is possible. And then you can do sorting, original order, sort ascending, descending, and all these different options are there which you can also turn on. And this is the final result that is coming, that is states which have got total population more than 1 crore and number of houses greater than 24 lakhs. Those are being highlighted from the map, and the data for that is also being shown. Now it is for you to decide, will you save this data in a separate table or a separate layer, or you will just either, and it's just a record, you don't need to save. So this is an older version of that SQL query editor. You can see that we can pick and choose the layer, then what fields we want, and then what values we want to choose within that, and those things could be then there are different operators, and like, or, not, then greater than, equal to, lesser than, all these things are there. And over here you can see these operators, underscore and percentages, which we have learned. These are for string operations, right? So we can use these wild characters like percentages or star for any length. Star is for any length, and for underscore for one character in combination with like. So if you remember our lecture from SQL, string operands and string operations in SQL, so exactly those kind of things could be also done over here. That means we can replace part of the text using this particular values, and then we can get the results as per our liking. So we can also go for Boolean operators, and we can also add and or not. Is null is to search for null values in the table. Get unique values results in only unique results, and then substring name T means whatever contains T should be returned, right? So you see, most of the power of SQL that we have learnt earlier, the entire set of things that we have learnt earlier could be also applied in the GIS context. And so you have to be very to do a lot of analysis and to show their spatial results together. So this can be done via this GIS. Then comes the more interesting part in querying in GIS, which is utilizing the power of, or the core strength of GIS, which is the spatial, the features that are provided. For example, we have got lines, we have got points, we have got polygons, right? So we have to, because that's something which is in addition to normal databases, right? So GIS also have those particular features which are in addition, right? And so we have to use the power of those to also do some very interesting queries. For example, query by location, select features based on spatial relationships with other layers utilizing the core strength of GIS. So for example, it is performed by using the select by location tool in ArcGIS, and for example, we can ask which buildings fall within a 500-meter buffer around a road or a river. So whatever buildings are within a 500-meter buffer, those would be highlighted. So this couldn't have been done in a normal table, because GIS allows us additional information, and it gives a spatial context that where is the river, how far away are the buildings. So we can do this sort of analysis, which is very, very unique to GIS, right? So then we can also combine two querying tools. For example, if I want to understand which buildings falls within a distance of 150 meters of a school in a map, then first I will using the select by attribute tool, we can select the schools first, and then we can use the select by location tool to see which buildings falls within certain distances or distance of 150 meters of different school buildings. Now, what kind of analysis, spatial analysis we can do? So this image actually shows you those things. So the different topological relationship that two geographic objects possesses. So based on that relationship, we can do a lot of these spatial queries. The first one is intersection and crossing. That means if a line is intersecting a polygon, if a point is intersecting a polygon or it is contained in a polygon, if a line is intersecting a point. Similarly, partial and complete in containment, that is if a polygon is contained within another polygon, if a polygon is intersecting another polygon, if a polygon is touching another polygon, then if two lines are intersecting, then shared line segments like A shared segment with B, right? So that's a shared line segment equivalence if both are same, A is identical to B, and then boundary touching and all these things could be also evaluated. So selecting features based on spatial relationship to other features in different or same layer. So this is again from an old version of ArcGIS. You can see that first we use features in one layer to select features in another. For example, over here select features in A that are completely contain B or intersect with B, are within a specified distance of B, are completely within B, we can check, right? So that means we have to have two layers, and the features from one layer and the features in another layer, those two could be compared, right? If they are overlapping, touching, intersecting, and so on. So over here you can see that we have to select features from buildings. This is and the source layer is plots new, and the spatial selection method is intersects the source layer feature. So that means these two things we are checking if buildings and plots new they are intersecting or not, right? But instead of intersecting, we could have looked into other things as well, like are within a distance of the source features, contain the source layer feature, are within the source layer feature. So all the different topological relationships that we have tested, that could be tested between these two features from two layers. So this is an example where we are showing you that we are trying to select boundaries. There are two layers. One is the West Bengal boundary, and the other is of course the district boundaries, right? So what we are trying to do is within West Bengal, whichever are the districts, we are trying to find that, right? So we will use within, of course, in this particular case, and within a distance or within a distance 3D or contains, all these things we can look into. So what we are doing over here is we have one layer input features from geo boundaries India ADM 2, and then geo boundaries India ADM 1 West Bengal boundary. So this is West Bengal, and then this is this all the district boundaries, and what we can do is we are seeing if it is we are taking intersect over here, that whichever is intersecting, and then we can see that these are the districts which are within the within the boundary of West Bengal, those are selected, right? So that means we are comparing from spatially that which are the districts which are within the or intersecting the West Bengal boundary, and those are the ones which are selected. Intersecting means it will somewhere it will be within that particular feature, but I think within or contain would be a better option for this. So this is a more relevant example. So here you can see that we have two layers. One is building, which we discussed a little bit ago, and then there are plots. So in this particular image you can see that there are several buildings which are marked, and then the plots are also marked. For example, this is a plot for for a sort of regional training camp for something. Then there could be a defense area, right? And then there could be individual plots, right? Within this plot there are three buildings. So if I want to understand that what is the amount of open area, right, after the buildings plots are there, and we also know the building footprint. So what is the open area? So how do I do that? So for that, I first am running a query. We are selecting by location where the plots are within the source layer feature. That means within the buildings, where the buildings are within the source layer feature, which is the plots, right? So accordingly, when I run that, you see this kind of a table coming. So that is for each plot, which are the buildings within that, those are also coming, right? So, and those are coming over here, and that means one plot can contain multiple buildings within, and the areas of each of these buildings are coming. And then we can, if we can write the query, and we can also do some calculations to add a particular column over here which says that the total area of selected building divided by total selected plot area into 100 is the percentage of area covered by buildings. That also we can add to this particular data set or the particular output. So that means you cannot do it by selecting just this thing, you may have to write queries in a separate step, and using that we can also add this new column which shows the percentage of area covered by buildings. So, percentage of vacant area of plot equal to 100 minus percentage of area covered by buildings. That also can help us to ascertain that if from two separate layers, we can compare these two separate layers and we can find where buildings are contained within the plots, and we can identify that what is the percentage of open area. Then we come to join, which allows us to combine attributes from one table to another based on a common field, and allowing enriched analysis such as attaching census data to state boundaries. So, suppose I have got a map of different states of the country, or different and then what we want to do is for each state, it has in the GIS map, like over here, like Puducherry, Maharashtra, Nagaland, you have got some information like its shape, area, and so on, right? Now I want to attach the census information for this state to this, which will have total number of households, total number of population, total number of male, female, and so on, right? So, but this data is not spatial. This is this is a separate data set. How we can do that? So I can attach CSV files, I can attach Excel files, all this to this particular between these two layers, or rather in my spatial data I can add that by selecting one field which is common between these two, and then we can create a join between these two particular data sets. So just you have to make sure that the field used for joining should have same characters in both the tables. So here we are joining a CSV census data to a shapefile, and in the contents panel, first you right click on the shapefile, which one you want to join, and then you click on join. Then once you do that, you the ones which you want to join with census data. So this one, that one you select, and then select joins and relates. And first, once you do that, then add join, and this one you have to select, and then in the add join window, confirm the shapefile is selected as the input table, and choose the appropriate input field. So you see the proper shapefile is selected, and then this input field is selected, right? So this is the join table, and the input field name is that is selected, and then under the join table, select the non-spatial dataset CSV file containing the census data. Choose the corresponding field in the CSV that matches. So first we are selecting the feature that we want to join. So that is shape name, and then we are selecting the CSV file, and then we are selecting the corresponding field in CSV, which is over here, and then we can click OK to execute. And then once it is done, then you see that this is the final table after join, where the first part is basically the spatial data which was already there, and then we are adding the data coming from the CSV file into the same data set. Now, this was a normal join between two files, two layers you can say, or between a layer and a file or a separate data set. But we can also do spatial joins as well. That means it combines attributes of one layer with another layer based on the spatial relationship, and again here we can compare this within, intersect, nearest, contents, and so on. So that means it will add two layers from two features from two different layers, or multiple features from two different layers based on again some criteria, which is that means that one feature could be within or intersecting feature from the base layer. So again we will this example we are taking from Learn ArcGIS. Some projects are already there, so we have taken it from there. And over here you can see that a polygon map for urban areas, which is visible over here. So that means this has got the polygons which definitely mark the urban areas in a particular region. Then what we are doing is so once we click on one of those urban areas, you can see that what are the features of that particular urban area as well. So over here you can see this urban area has got an area, then it has got a shape length, shape area, and so on and so forth, right? And similarly, we can have another table or another feature which is populated places, and we can also turn it on, and you can see that populated places points, that means these are different points which are showing the different location of different populated places, which would obviously some of them would be within the overall urban area. And so both of, in some cases we are seeing that some of the urban areas have got these populated places within that, right? So after zooming, once we do that, then we can do the join, spatial join. So we go to the the base one, that is in this case the urban areas, and right click on the shapefile to which you want to join, and click on joins and relates, same way which we have done earlier. Add spatial join. So instead of add join, we are now going to choose add spatial join, and in the dialog box we have to also set which is the target feature that we want to join, and also what kind of join it is. So here we are selecting intersect, and the target feature is from urban areas. The populated places is the actual feature, and then based on that, what we can do is we can run it, and we can show that for every when we are joining, that means both of these, that means the populated places as well as the urban areas, both are displayed together, and these are all combined now. Then comes something called relate. This is more about relationships. That means we can create, when we have got many layers and each layer contains different types of data, and this data is joined. For example, layer 1 is US state boundaries. There will be polygons for that. Then layer 2 would be US county boundaries, and then layer 3 would be populated places of the US. That means cities and all. So we have state, then there is county, then there is this populated places. So the idea is when one is selected, then we can also select the others, because those are related, right? Because there is a hierarchy. So a relate links two tables through a common field or attribute without physically merging them, useful when one-to-one many relationship exist. That is one word linked to multiple infrastructure records, or one state having many counties, or one county having many populated places. So when a record in table A is selected, the corresponding records in table B would be also highlighted together. And unlike join, in a relate, it actually doesn't append the data, it doesn't create a new data set and all. It is, and that means it is just to create that relationship, so that whenever you click on one, the other related information from other layers will also get highlighted. So to start with an example, we are joining state boundaries to counties. So we select, this is the state boundary layer, then we click on joins and relates, and then we add a relate over here, and after that we select the add the layer name, input field, relate table, and the output relate field. All this has to be set over there, and once we have done that, so this is the relate table and this is the relate output field, and once we have to also set the cardinality, that is what is the nature of the relationship. It is one-to-one, one-to-many, and so on. So this is one-to-many, and this is saved as relate 1, and once we do that, then we can see that for different states, which are the counties, those would be also coming. So this state, whenever I am clicking on Plymouth, which is a county, I am also getting the state is Iowa. Then same way we can join state boundaries to populated places and counties and all together. So same way we have been doing. So we add a relate after clicking on that measure, and we can we are doing the exact same thing. Over here what is happening is, when we are selecting on state Indianapolis, then Indiana, and then county, and then all the different populated places, that would be also Backford, Benton. These are the different cities or the populated places which would be also connected and shown together. So this is just creating a relationship between the different tables or different layers, and then to show connected information together. So these are some of the references that you can use. To conclude, GIS querying is similar to SQL querying in databases, but enhanced with spatial logic, enabling planners to analyze both data attributes and geographic relationships simultaneously. Thank you.